Yeah. Why are you like, are we grafting in any sort of way? We might be grafting. What? I don't see.
All right, as for today, gonna wrap up chapter 6, maybe do a little bit more. So last little bit of chapter 6 here. We have, yes, a little bit of graphing. Oh, so good. Because, all right, we are finally graphing a new shape. All right, so up till now, we have only graphed what? Shape is a strong word. What? Yes, a line. What system? All right, we've only graphed lines. But, all right, with, what is it called when it has a x squared in it?
What? Sorry. Exponents?
When the function, the whole thing, x squared minus plus other stuff.
Quadratic?
Quadratic, all right? But when you graph quadratics, they look a little bit different. All right, so with a line, how many points do we need to graph a line?
2.
2, all right? But with quadratics, all right, you need a minimum of 3, and actually it has to be the correct 3. So what we're going to do is we want to get approximate sketches of what a quadratic looks like graphically. In order to do that, we need to find the x-intercepts and the y-intercepts. So let's start with the easy one. The y-intercept, right? Which again means set x equal to 0 and solve for y. Well, in our equation here, that becomes, all right, put in zeros for all the x's. So that becomes y equals
0,
-5. And then our intercept is then the point 0, -5. Similarly, all right, for the x-intercept, set x equal to 0, y equal to 0. And solve for x. So we have an equation that we've actually been working on, x squared minus 4x minus 5 equals 0, in order to solve quadratics, all right? What's the fundamental part? Ignore the equals, and what do we do with that thing?
Factor?
Factor, right? Everything basically comes back to factoring. So ignore the fact that it's equal to anything and just focus on factor. X squared minus 4x minus 5, and we put the equal to 0 back in later. So how do I factor a quadratic? The diamond. Hannah's favorite dance move, by the way. All right, so with this, all right, what multiplies to -5 and sums to -4?
1 times -5.
There's only one option. This is then the special case that I can jump straight to the factors. X minus 5, x plus 1. I can do that in this case because, why?
coefficient of x squared is 1.
Right, the coefficient, the term in front of the x squared is a 1. This is the only case, otherwise we have to do the full diamond, right? The AC diamond, the big diamond. Once I have that, now I can put the x minus 5, x plus 1 equal to 0, can put it all back together. And this, remember that once you have it in factors, things being multiplied, this is essentially, this breaks into 2 individual equations to be solved by the zero product property. And then I have 2 super easy things to solve because factoring broke it all down, all right, in order to solve it. And oh, look, x equals 5, x equals -1, giving us our intercepts. 5, 0, and -1, 0. So that's all the same stuff we did last time. The only new part is now we're gonna draw the picture with this. But, all right, I have a y-intercept and I have 2 x-intercepts. So now to our picture. And again, every time, just to reemphasize, when I have my graph, what's the first thing I should do? Draw your x and y axis, right? Re-emphasize those. So they're nice and clear. Then I'm gonna put all my points on here. So I have the point 0, -5. I have the point 5, 0 and -1, 0. All right, so I have 3 points. Does anyone have a guess of how this is gonna look, or does anyone know what a quadratic looks like? It looks like a U, all right? It is all referred to as a parabola. All quadratics, all right? They are parabolas. And basically U-shaped. The only thing we need to know, just like with lines can be positive sloped or negative sloped, we need to know if the U is faced up or faced down. You can tell that literally by the coefficient in front of the x squared. If it's positive, it's faced up, all right? If it's negative, parabola is down, all right? So that's the only other thing, just so you know how to approximately connect those dots. Now, with this indication, I was pretty sure it was gonna be up. And then all we're looking for here is an approximate sketch, and this is one of the times your graphing calculator can help you out if you want a more precise sketch. But all we're looking for is to try and make an approximate sketch here. All right.
So positive is up, negative is down.
Yes, all right, for the coefficient term. If A is greater than 0, it's that. If A is less than 0, it's that. Notice I did not have A equal to 0. If A equals 0, what happens?
Can't graph
I can definitely graph it. It would be what?
Maybe.
That's actually pretty close. If A equals 0, all right, this 0 times x squared goes away. Now what do I have? What is this? Y equals -4x minus 5.
Just a y-intercept, or the slope intercept.
It's a line. That's just a line, right? So, all right, because that term, all right, has to be, you have to have the x squared in there to be a parabola. And yes, so all I want you to be able to do is draw an approximate sketch, all right? Now, we can go way more into depth, all right, about where the vertex is, right? Where it goes from decreasing, increasing, all kinds of fun stuff. But you can leave that until your next class. Lots of fun there. All right, then the good stuff. All right, knew there had to be applications. There's always applications. Lots of things are actually demonstrated by quadratics. All right, things that increase and then decrease. They have a single peak or a single minimum. All right, a big one. All right, lots of drug applications here. For certain people suffering from an extreme allergic reaction, the drug epinephrine, aka adrenaline, is sometimes prescribed. The number of micrograms N, right, of epinephrine in an adult's bloodstream after T minutes is 250 micrograms, having been injected at approximately, by the equation, N equals, right? So we have the number of the micrograms, and then T is represented as time. How long after injection will there be approximately 210 micrograms of epinephrine in the bloodstream?
When you just said that equal to 2.
Yes, that is all you have to do. My point, as always, every time we do word problems, is don't panic. Oh my God, there's like a million words. I don't know what to do. And then I just see it left blank. Don't panic. It is not overly complicated.
That's you. It is me.
N equals 210. All right. Micrograms, all right, and N equals negative 10t squared plus 100t. Set the two of them equal. And then I have a simple equation to solve, all right? Yes, there is not that much to do, but without a doubt, as soon as someone sees like, oh my God, there's like 3 or 4 whole sentences there, I don't know what to do. All right, take a breath and set it up. Because once you have the setup, then it's just a matter of applying all the techniques that we've been talking about, all right, to solve this. What do we need to do? No, not with quadratics.
The 210 to their side of the.
Need to get this equal to 0, right? All quadratics must be equal to 0 to solve. So that's always the big step. All right, must get it equal to 0 to solve it. Then what do we do?
Do you make the t squared positive?
Okay. You guys are both correct. But the big part is greatest common factor, because basically this is what I've been saying. Ignore the equal 0 part and just factor it. So basically now I have negative 10t squared plus 100t minus 210. All right, and then we factor it. And Anna, you were exactly correct. Greatest common factor. To that end, 10 is the greatest common factor, but to make that even better is, how about negative 10?
How do you take negative 10? You multiply it by negative 10.
So by pulling the negative 10 out, we did something super important. What's the coefficient of t squared?
1.
Positive 1, all right? Which means that I know when I do my diamond, I can jump straight to the factors. So it's super helpful, because if the negative is still in there, I can't do the quick diamond. I have to do the full diamond. So pulling that negative all the way out, very, very helpful. Then we get to do the diamond. What multiplies to 21 and sums to negative 10? I thought I heard it. Negative 3, negative 7. Then we can add the 0 back in, and now we can solve this. Now, one other quick thing, you can set individual factors. When you have variables, you can set those equal to 0. But this -10 out front, in order to actually deal with that and specifically to get it out of our way, divide both sides by -10. Because watch what happens. -10 divided by -10 cancels on the left side. And 0 divided by -10 is, oh, 0. Okay, so that doesn't have a variable in it, so it's not break all those up, because you'd have -10 equals 0, which is a contradiction, which means something went wrong. Then I'm back to this, and I have two individual equations. All right, so we got that. Now back to the question. Okay. So how long after injection will there be 210 micrograms of epinephrine in the bloodstream? So is the answer 3 and 7?
No.
What is it?
Read this. No.
Huh?
Do you add them?
No.
No.
Remember what this is gonna look like. So looking at the equation. Looks like this. Right here, here's 3, here's 7.
Between 3 and 7.
Is it between 3 and 7? Okay, and we're getting off track of what I'm trying to identify. Is the answer 3 or 7? 3 is the answer. 7 is the answer.
Is it both?
It is both. So 3 and 7 are the answer.
Then 3 and less than 7.
Okay, it's not an inequality.
I know now.
But the important part, this is a word problem. What do I need to attach to that 3 and that 7? Units, that's all I'm looking for. 3 minutes, 7 minutes, all right? And the point is that like most drugs, there is the drug is getting into your system, then there's a peak, and then it starts leaving your system, like everything that you input into your body, right? So it does have 2 solutions. But my point here is 3 and 7 minutes. That's what we needed to attach our
It
units.
can't be 3, 2, 7.
It is definitely not 3, 2, 7, right? Because, right, again, what the graph looks like, there is some peak here, all right? At, I don't know, about what, at 5 minutes, although this probably isn't
So it's
perfect.
going above.
Yeah, it'd be above 210. We were just trying to find exactly when it's equal to. If it said when I would have at least 210 micrograms of epinephrine in my system, then that would be between 3 and 7, right? So remember our wordings that we talked about, and saying something like that actually makes more sense.
So, so when you said before 210, what would make it after 210 grams?
Make it after 7 minutes?
Yeah.
Oh, well, obviously that's less than 210 grams. So I don't know, whatever between 0 and 210 is whatever this number is, wherever this crosses here, all right, when the epinephrine has completely left my system. And this is a very, very common application, right? This is how all drugs in your body work, right? You take the drug, it slowly absorbs, it's increasing in your bloodstream, it has a peak, and then it decreases, and then you have to take more drugs. All right, one other big application of quadratics is the Pythagorean theorem. This is also referred to, what, Anna? It should be everyone's favorite. This is also referred to as the fundamental theorem of geometry, all right, because it is so common, all right? It deals with right angles, just in case, a little refresher, all right? The 2 values off of the right angle are called the legs, and just notationally, to indicate 90 degrees, we typically put that little box there. the side across from the 90-degree angle is referred to as the hypotenuse. The sum of the square of the two legs equals the sum of the square of the hypotenuse. It is a super simple theorem, but people forget this so often. And this is one of those ones that you should definitely either have on your cheat sheet or ideally just have memorized. All right. The most famous one, all right, is the 3, 4, 5 triangle, right? You guys remember hearing that? The 3, 4, 5 triangle and every multiple of that, 6, 8, 10, the 9, the 9, 16, 25, every combination of 3, 4, 5 creates a Pythagorean theorem. All right, that is the perfect Pythagorean theorem right triangle. For us, all right, we want to be able to identify an application. So
Making a square deck, that's your application.
what?
Making a square deck.
Square, oh, a deck.
Measure that
Deck.
far out, that
Yes.
far out, and that better equal or you ain't square.
So there is a telephone pole of unknown height. There is a guide wire that is 40 feet long. All right, from the base of the telephone pole to the guide wire is 15 feet. How tall is the telephone pole? All right, important note about this. Notice, did this say, oh, I have a right angle and all that and use Pythagorean? So you have to understand when to use Pythagorean. Now, so I have a telephone pole. Are telephone poles ideally perpendicular to the ground?
Yes.
And ideally is the key word there, okay? So the idea is that you understand that, oh, okay, if automatically I have something that creates a right angle, I should use Pythagorean theorem. So we have, all right, our telephone pole. All right, we have a distance from the ground and a guide wire. Guide wires, all right, typically go from the pole down to the ground. We are told that guide wire is 40 feet long. All right, telephone pole is what we're looking for, and the telephone pole to the guide wire is 15 feet. So the idea is that you can create the triangle with the information. And then it says how tall is the telephone pole. The only trick here, all right, I mean, once you get the picture can be a little tricky-ish. Then making sure that you plug everything in correctly and then just a little bit of solve. So we're going to go through this. All right, so the hypotenuse side, 40 squared. 1600. 225. And then pretty easy solve. Then, all right, the only thing is that remember we are solving for the telephone pole. So what is the only thing I have left to do?
Square root.
Square root. All right, way too often people are like, oh, I plugged it all in. But don't forget that that's actually x squared. So remember, we're trying to solve what we have called this guy x. Which gives us 37.08. Is that correct? Everyone okay with the calculation? Good. That's the right answer.
Feet.
Feet, units, units, units. All right. Again, if you started, the idea is if you start in sentences, you end in sentences. But at minimum, you need to end with words somewhere, right? Ideally, I would say the telephone pole is 37.08 feet tall. Okay, out of laziness, I just put. Okay, but, all right, definitely units are crucially important. All right.
Change.